Anyway. So, yeah, as Warren mentioned, this presentation will be about 1 year review of Group123. Different campaign we were able to identify. Some are very similar and some are really different, targeting completely different region of the world. And at the end, you will see that this team is growing up, have more and more skills. And in January this year, they start to use 0 day. And we will explain to you everything at the end. It will be Warren. So about me, I'm Paul Rascagnères, so I'm French. Sorry for the accent, it's not my choice. And basically, I'm malware analyst and threat researcher at Cisco Talos. I work on several cases, such as CCleaner, Group123, I will present to you, Olympic Destroyer, and a lot of different fun stuff like that. And yeah, that's the slide issue, for example.
Black, white, oops. Oh, nice. Nice. And that wasn't me.
Someone has the same pointer and playing with us?
Oh, maybe actually.
Yeah.
So yeah, I work with Paul. I work at Cisco Talos, malware researcher, threat intelligence hunter, etc. Paul and I work on pretty much everything together. So CCleaner, Olympic Destroyer, Bad Rabbit, etc. And what we're going to go through today. I don't apologize for my accent because, like Steve mentioned earlier, I'm finally in a place where everyone understands me, so it's great.
So here is the timeline we will speak today. So first campaign, it's not the first one we identify, but it's the first one on the timeline, is a Golden Time campaign. Here, it was due during 2016 and until March 2017. So basically everything, on this group more or less all the time, everything starts by email. In this campaign, the attackers use an email from an event named Korea Global Forum, so it's a real conference, and it's hosted by a university, and the email really comes from the university. If you look at the header, the mail really comes from server from university, so basically attackers compromised this account and was able to send the email. I think everybody speaks Korean here? Yeah, of course, so I won't translate. No, I'm kidding. So basically you have an attachment and it's a HWP file. In fact, in Korea, they don't use Office, Microsoft Office. They have their own Office and it's named Hangul Word Processor, HWP. But you will see it's basically the format is very close, but it supports their characters, in fact, which is complicated for Word, and they have a lot of tactile device, and they are able to write directly on tactile device, and it translates on Korean, and it's really useful for them. So they have their own file format, HWP, and this document, it's basically the forum send this email, we assume, to several attendees, and it's a survey when they ask to open attachment and say if it was good, bad, etc. Another example during the same period is this one. This one is completely different. It's someone we are alleged to be in North Korea that sent an email and asked for help and how we could move in south, etc. So it's the same thing, an HWP document, and in this case, the attackers work on the empathy of the target to open the attachment. Both documents, the form for the conference, and the email saying I was born in 84, etc. So let's go on the HWP document. So as I said, it's a kind of Office document, so you can use all of them. If you are used to analyze Office document, it's a tool, an open source tool you probably use often. The biggest difference is you have object, but the object are zip. Z-lib compressed. So it's the only difference. So the tool is able to list the object, but is not able to extract and read the content, because you can extract it, but you need to unzip it before working on it. So yeah, in this case, you have an EPS document. It's embedded PostScript, something like that. And they use a vulnerability in the EPS parser. They use a well-known vulnerability, so this mail was sent in 2017, I think, and it's a vulnerability from 2013, so it's an old one. And something if you are used to analyze shellcode, generally you've got a lot of 90. It's NOP. You've got 90, 90, 90, 90, blah, blah, blah. In this case, I think it's to avoid detection. They use 04040404. It simply make a useless add on register. So I think it's simply to bypass some detection. The purpose of this shellcode is to download 2 fake JPEG on website. You will see this actor really love JPEG file. He always tries to download JPEG file, but it's never a real JPEG file. It's the real payload. And the website are legitimate website. He compromised website, put a fake JPEG file, and use this file for the second stage of the compromise. In this case, you can see WP content, it's WordPress. So each time you have a public vulnerability on WordPress, he compromised WordPress website, put his malware on it, and prepare a campaign. What is the purpose of this JPEG? So it's obfuscated with several boring stuff. But anyway, at the end, we have a sample. We name it Rockrat. It's a remote administration tool. The purpose is basically to have world control of the remote system. And I'm going to explain real quickly some of the features we found on them. First, he checks the version of your system. And if it's a Windows XP, it simply go on infinite loop, because nobody has Windows XP normally, and it's basically used by sandbox system. So if you have Windows XP, he think it's a sandbox. We do nothing. He look on running process, and it's really common to check for analyst tool, such as, I don't know, Wireshark. And in this case, I think it's the same reason. It's to avoid detection. He doesn't look for the complete word, like, I don't know, VBox, like Wireshark. But he's looking for Wireshark. So if you make detection based on the word Wireshark, it doesn't work. He looks for small subpart of this specific process. Here is the complete list. It's really, really common analyst tool. If the malware finds one of this tool, he makes something really, really weird. He starts watching a TV show. It's a Japanese TV show, and he's starting to watch the TV show. We don't really know why. And the TV show is, I think, a Japanese or Korean TV show named Golden Time. That's why we named this campaign like that. So if you execute on Sandbox, and your Sandbox is a Windows 7, but the malware detects one of this tool running, he will download this TV show and start watching it. So the infrastructure for this malware is really specific. Usually you have a server and you send data to this server. The server gives order to the compromised machine, and it's how it works. In this case, it's completely different. The attackers use legitimate platform in order to administrate compromised system. For example, here you've got a Twitter account. So the malware uses the Twitter API to get the infected machine and give order to this machine. It's clever because on some organization it's really hard to block Twitter because it's used sometimes. It's normal to be used inside of the organization. And Twitter, of course, uses HTTPS. So it's boring to make massive SSL interception in your company. We identify 7 hard-coded Twitter tokens on the binary. Another C2 channel in this case was Yandex. It's a cloud storage platform. It's really famous in Russia, maybe not here. It's like a Russian Google Drive, more or less. And same thing, the exfiltrated document was stored inside of this Yandex drive. We found 4 different tokens in the binary. If it doesn't work, they have a Bplan, a Mediafire cloud platform. So same thing, they send file directly on Mediafire and download them after. And yeah, it's like more or less every remote administration tool today is able to perform a screenshot of the machine. And yeah, it's simply IDAS capture to say that. So it was the first campaign. And we identified a second campaign, more or less in same time. We named it Every New Year. And in this case, it start by a malicious HWP document, so like previously. So basically, if you see HWP document, it means you target Korea because nobody else uses this file format. And in this case, it's in Korean. And if you look at the logo and the text on bottom, it's the logo of the Ministry of Unification. So it's a Ministry of South Korea, where the goal is to have one day a unified country between North and South. And the name of the document is North Korea New Year Analysis. So basically, it's a document that speak about the last speech of a North Korean leader, and they explain which word he chose and why and how to interpret it, etc., etc. In this document, you have two links. It's mentioned, you can click here to have more detail. And obviously, if you click here, something happens. It basically drop executable on your machine and execute this file. Here is threadcrit sandbox output. So everything is red, of course. And it's a document. It's basically 2016 and 17. The word choose during the speech in 16 and the word choose during the speech in 17, and why the leader choose this one on this one. It's really geopolitical interpretation of the end of year speech. What was the purpose of the dropped executable? It was to make a fingerprint of the system. So first, he got the computer name. Secondly, your username, execution path, so where is executed the exe. If you look, it should be there. But the attackers get the path. And finally, you get a specific registry key. This registry key contains your BIOS model. And if you use VirtualBox, for example, you have VirtualBox mentioned here. So all this information are sent to the C2 server. And here an example of the data sent from VirusTotal. So the hostname, Tequila Boom Boom, is the hostname of the virtual machine of VirusTotal. The username is the username of by default on VirusTotal. And you have a path. So VirusTotal executes the binary directly from the root of your file system with the hash. The file name is a hash. Basically, if the attacker is waiting that, and he receives that, he will say, it's probably not a real machine. And at the end, you've got the BIOS model with VirtualBox 1.2. And how does it work? In fact, this data is sent to the PHP file here. And if it matches the expectation of the attackers, if the path is the correct one, if the name is the correct one, if it's not VirtualBox, it generates a JPEG, another JPEG, and this JPEG is downloaded, and you have the final stage of the malware. It's how it detects sandbox. And if you look at the domain, kgls.or.kr, it's a real governmental website in Korea. So they compromise this website to put PHP page and JPEG. And the point is, you don't blacklist governmental website normally, or you have really, really good reason. And here is the map of this campaign, the different servers, the JPEG file, etc. Another one, it's completely different than the previous. The two previous ones were really close, but this one is completely different. It's a campaign named Are You Happy? It was between February and April. And in fact, on Rockrat, we have some strings, and on these strings we were able to see that a module was named ERSP, but we were not able to get it on the previous campaign. We know it exists, but we did not have it. At this time, we finally have a way to have this specific ERSP.NT sample, and once we analyze it, we understood what means ERSP. It's erase partition, and it's a wiper, basically. He'd open your physical drive and wipe your disk. And he put, are you happy question. So when you reboot your system, you simply have a black screen mentioning, are you happy? So that's why we named this campaign like that, of course. Another campaign, always by the same guys, completely different, is a campaign named Free Milk in between April and June. And in this case, the guy didn't target Korean entities. So they cannot use HWP file because it doesn't make any sense outside of Korea. So yeah, nothing fancy. They use Office Document because it works. They use a public CVA at this time, and the purpose was to download an additional HTA file stored on a compromised website. If you look at the source code, maybe it's too small for you, but JPEG, as usual. They don't know the additional JPEG file, and it's obviously not JPEG file. And here is the sample dropped. It's named Poo Milk. We didn't choose the name. It's chosen by developers. It's on the PDB, the compilation path. We can have Poo Milk name. And the purpose was to execute another binary named Freeman key. And it's same thing. It's not our name. And yeah, it's a remote administration tool. The purpose was to have access on the machine and be able to do what they want to do. Yeah. Now it's your time.
So that was like the first sort of 8 months of when we started to observe this from an interesting campaign point of view. And if you notice, July and August, maybe not so much September, but July and August are summer. So these guys clearly take time off. They got through June and thought, let's have a rest. And then they didn't do anything for 3 months that we observed or that any other person, campaign, vendor, etc. observed. So we picked them up again November time. Actually, early October time this would have been. Early November, late October. And what we found was the North Korean human rights campaign. Again, we see the HWP thing. HWP is a really cool format to analyze and look at if you're into malware research. I don't know if anybody has ever looked at it, but as Paul said, the Ollie dump tools work really well on it. One thing to sort of note, there's always a default JavaScript element there. It's generally nothing, but generally if you see JavaScript in an Office file or whatever, it's something bad. But with HWP, it's default, it's there. So look out for that if you are looking at it. So this was apparently written by a lawyer, and it was basically saying, hello, we're representing the community of North Korean human right and unification people, and we're basically wanting to discuss with all these other peoples how we can make people more interested in the activities that they're trying to do. No one reads Korean, so let's hope it says that. But yeah, we have Korean linguists, so we knew it says that. And what we were able to do is actually start looking at this and see, okay, what's it doing? Obviously, as some of the other campaigns Paul went through, generally it's pulled down a malicious script, whether it be PowerShell based, whether it be just a binary payload based. And what they're looking to do is pull down something more interesting and different here. So what we found was a base64 encoded payload. So we pulled that down and actually used WScript, so Windows command scripting. Decoded it, dropped the payload to the disk, and then executed it. And that was the malicious script that contained that. What we found there was process injection. So this is an excerpt from IDA, and what you'll see is any command exe. You probably can't see that actually. Trust me, it says command.exe, and it's doing process injection using command exe. It does a virtual allocate, and it does a write process memory, and create a thread, and we get a way in for the attacker to then inject his own information, his own library, his own payload, etc. So from here, we started to get decoy documents, and the ones Paul talked about. We got decoy display pictures. We don't know what any of these are. They're just random pictures that appeared in some of the resource files of the payload, wasn't it, we found those in? So they don't mean anything to us. We weren't really able to find anything on Google about these.
Some of the picture are publicly on you got some picture on Wikipedia, for example, and it's always a link to, I would say, tension between North and South Korea.
So you'll see it's slightly military-based looking, top two and the bottom two. Middle two are most likely politicians, political activist type people. So what do we find? Because that's the interesting stuff. So we found a new variant of Rockrat. Rockrat is something we tracked for a long time. It's called Rockrat because of Republic of Korea rat. It primarily attacks, I say primarily, it only attacks Korean-based users and Korean-based victimology. It has now anti-sandbox techniques, and it has library existence checks for all, I want to say major, but some sandbox platforms out there, so Sandboxy, GFI, and Microsoft debugging tools that may be in use. We found stealers. So browser stealers are effectively pieces of malicious code that will try and steal any username password combinations that you use. Because I'm very lazy, and when I click on a website, and I've been there before, and it says, do you want me to log in? I'm like, yes, because I don't remember all my passwords, and no one does. So don't say you do. This can happen to all of us, is my point here. Be careful where you store your information, where you store your passwords. So the anti-debug that we started to see, so I use x64 debug, so this never happened for me. Paul is stuck in 1970s and uses per debuggers like WinDBG and Immunity and OllyDBG. And what we found here was an anti-debug or a compilation error. We're not really sure. We've seen it in other platforms and other pieces of malware, etc. What this basically does is crashes the debugger, which stops you from trying to debug it, is the long and short of it all. So that was the first instance of anti-debug that we saw within Rockrat. We then seen this again, the use of legitimate cloud platforms. These are really hard to block because, well, maybe Yandex isn't because it's Russian-based cloud storage. I doubt anyone has a real reason to use those. Pcloud, Box, and Dropbox are legitimate resources that lots of European markets use. So these make it really difficult to actually block. That matches in with Twitter being used with the last one, Mediafire. Again, Yandex might be something you could have some sort of reason or rationale for blocking. By using these, traffic analysis becomes difficult. It's all HTTPS, it's all API based, it's very difficult to crack on basically. So what they've done is been really sensible with the people they're trying to attack. Using this kind of infrastructure doesn't mean I have to go and compromise a box somewhere like they did in some other campaigns, but these are much easier platforms to get access to and much less likely to be blocked. And then we've seen the Evil New Year 2018 campaign. They like New Year, clearly, because they did this for the last 2 years. Evil New Year 2018 campaign was the same sort of idea. It was the Korean Ministry of Unification again. The idea here was a spearphished email sent, and that spearphished email was, here's the latest analysis of the last Korean speeches that have been performed, blah, blah, blah. Please open this document to find out all the information. Of course, when you open that document, you get a Hangul word process document with an encapsulated PostScript file. And within that object is more shellcode. What do you think that shellcode does? Downloads a JPEG. What do you think that shellcode does? So what we find is that shellcode actually executes Rockrat in memory, and that was the first fileless campaign we've seen of Rockrat. Rockrat generally was download a JPEG, but this time it actually wasn't. It executed Rockrat within memory. So it was the first time we've seen the real sort of evolution from let's compromise this random website, let's put a JPEG up here, let's pull a JPEG down. Oh, that worked really well. Let's do that again, and then now let's run it as a fileless malware and execute it in memory. So what do the links look like? They all, note the typo, there's a series of typos coming up, so please ignore them. They all had the same reconnaissance phase, and that reconnaissance phase was looking at certain objects or registry keys within the system to tell what type of machine it was. Fingerprinting a victim is very popular by the more sophisticated actor. They don't want to waste time compromising someone they don't want to compromise, basically. So you try and determine who you want to compromise, why you want to compromise them. This is a graph overview from IDA that shows not a lot from this point of view, but basically what we're trying to say here is they have the same reconnaissance profile, so they're using the same paths, entries, functions, etc. The reason why we have two is they're two different samples, but you can see they look pretty much identical from a call perspective. Similarities that then existed between Rockrat and Free Milk. So Free Milk was actually discovered by Palo Alto, I think. Not by us, but we were able to do obviously the linkages back to see what we had. So we see the use of browser stealer, so i.e. Chrome, Firefox. We see the use of this Vault CLI DLL, and then all the Vault enumerate API cases that are used, functions that are used to try and get that information. And what we're trying to do as an attacker is select your username, password values, and take that off from the login information. Basically, we want your username and password for credential harvesting. We then obviously look for some more. What's really interesting to look for when you're dealing with non-native actors is file typos. So registry, we all know is not spelt like that. However, this attacker maybe has made the assumption and they've typed it in and they've reused that code, and you can then use that to track campaigns. Similarly to some of the stuff Costin and Chris were talking about earlier, if you're writing Yarrow rules, this is a really, really easy Yarrow rule to capture this kind of stuff. Really easy. You just look for ASCII code that says registry spelled incorrectly. Very simple. So again, we start linking it to those campaigns, which is how we were able to say Rockrat is also Free Milk. PDP patterns, so this is that's really hard to see, sorry. Compilation path information that you can determine. So we're able to look back at all the samples that we've seen, and you'll see that they go from version 12. What's after 12? 13. After 13 was 13 First Dragon. He's feeling particularly good that day, this person. But we're looking at the DocPrint PDP path and then the DocCall PDP path. So these are different campaigns that we watched. And then the last one, Wiper, again, you see the high school version information. So that's how we're able to use those small linkages. These are not things that attackers are going to put in. These are things that an attacker could put in potentially as a false flag, but it's more likely that this attacker has reused code and reused same sort of engine and staging information to be able to create this. Last one, Flash 0 days, because everybody loves 0 days. So the KISA, which is the Korean cert, as I say, Paul and I have a fascination with Korean malware, as you've probably realized. They published an advisory for February, I think, 2018. And this basically said, in Korean, there's a Flash 0 day. And that's it. It's like, right, okay, that's really helpful. So we were able to start finding out a bit more, and we determined, okay, the Flash 0 day is actually related to this, because Adobe released a security advisory. And we were able to say, let's go back now and look and see what we found in terms of what we've seen with Rockrat, etc. So we found an Office document, and in that Office document was an embedded Flash object. Sorry, I don't want to walk in front of the screen. That embedded Flash object then executed a connection to the first command and control channel, which was a PHP file. What this did was obtained an decryption key to decrypt the second Flash object. So the first Flash object launched had an encrypted blob included in it, but had no decryption key. Decryption key was created in a remote server, so I needed internet connectivity. So if you're running this in a sandbox with no internet connectivity, it didn't do anything. First stage, grab the decryption key, send the decryption key back to me as the victim. I will then decrypt that encrypted blob within this Flash object, and I will give you another Flash object. And within this Flash object is where they started to use that CV. They then downloaded a JPEG. And what that is shellcode. And they pulled the shellcode back down again, and it started to decode the PE within the exploit that they've used, created execution of W script, and then had Rockrat injection that we've seen. So we've went from, let's send a spearfished email. Okay, that's fairly sophisticated, particularly when you're compromising colleges, etc., to be able to send it. You're compromising government platforms. So we've sent those. Let's now hack a couple of boxes and use things like pcode and Yandex. Okay, we've done that now. Okay, it's like they had a checkbox of fun things they wanted to do. And then they came to Flash 0 day. What's really interesting is when attacking groups and actors like this start using 0 days, it shows their evolution has came to a peak. Either they have lots of money to be able to buy these exploits, or they've got lots of very good, very skilled coders and developers that are able to look for these exploits. Obviously what we got was Rockrat, as I mentioned. He's still in high school, as you can see, and he's still using the same PDP path, so we're able to link it directly to Rockrat again based on that. Conclusion of all that, sophisticated attackers will use multiple methods of tradecraft. As I was discussing, they'll send you an email one day, they'll maybe send you a Flash object another day, they'll maybe send you decryption keys another day. But we step through and see the clear evolution of Rockrat that we've seen in 1, 2, 3, 4, 5, 6 campaigns over a year period. We've seen them move from not using browser stealers to using browser stealers. So we've seen them up in their game in terms of what credentials they wanted to harvest. We've seen them using HWP documents in some instances. And then within Free Milk, the first time they attacked a non-Korean victim, where they were using Office documents. So they clearly have capability to be able to create, I say useful like that, but I mean from a malicious perspective it was useful. They were creating useful documents across both HWP and Office platforms, so they clearly had the skill set to be able to do both of these. And that is us. We find this very interesting. If you know anything about it or you want to talk to us about it, please feel free. I don't know if you have any questions. If you do, please ask. Otherwise, thank you.